All right, so let's work on this and try to get it from having exponents and powers down to nothing there. So first things first, we're going to take everything to the 5. So that'll give us 3 to the 5. Then x to the 2 to the 5th, that's going to give us x to the 10th over. Now we have 5 to the 5th. Then we have y to the 6 to the 5th. So 6 times 5 is 30 times. Now this, all we have to do is rewrite again. So that's a 5 squared y to the 7th over 3 to the 4th. Now here we notice we have an exponent to the negative 5. So if we take it to the numerator, that's going to make it a positive 5. So let's put up here x to the positive 5. Okay. And how we did that is it just, if you have it in the denominator, it's negative. If you take it to the numerator, it's positive. Same thing if we had x to the negative 5 over 1, then that's the same thing as 1 over x to the positive 5. So trying to get things always to be positive, we just take it to the other side. Wherever it starts, it goes to the other side, becomes positive power. Now let's go ahead and start canceling where we can cancel. So 4 of these are going to cancel 4 of those. So that means we have 1 left over. Now 2 of these are going to cancel 2 of these, and we have 3 left over. 7 of those are going to cancel 7 of those. So we have 23 left over. And then everything else is just going to be kept. So we have 3 to the 1. Now we have x to the 15 times x to the 5. So we add our numerators. So that'd be x to the 15 over. Now we have 5 to the 3rd. And we have y to the 23. And everything else is canceled. And so that should be our final answer. And if we look here, we have the numerator and we have the denominator. So that looks good. Okay. Now let's go to the next one. All right, so here we're having everything to the negative 2 power. So 2 ways we can work about this. We can say instead of saying to the negative 2, we can make it to the positive 2 and flip everything inside here. So that would look like, so converting to that, we're going to have a 7z squared over 28z to the 6th. And now this is a positive 2 instead of the negative 2. So all we did was flip everything. Now we can go ahead and take 7 and square it, and that's going to be 7 squared. Z squared squared is going to be z to the 2 times 2 is 4. Over, now we have 28 squared. And then we have z to the 6 squared, so it's going to be z to the 12. Can't think here. Okay. And so then after that, what we can do is we can start reducing. So this is going to be some big numbers. Now that I've got it to this point here, I see I have a 28 and a 7, both of them squared. It might have been smarter at this point to say, hey, let's take 7 goes into 28 4 times. That way I don't have to work with these big numbers. So I wanted to kind of show you, you could do it with big numbers, but if we reduce it first, that instead gives us, we could have a kind of a different equals path. That would give us a z. Now we have z squared squared, so it's z to the 4th. And then we have 4 squared. Then we have z. Well, and notice here, actually, you know what, before we do that, we can cancel here too. So, but let's before we do that, because 2 of these, we'll cancel 2 of these, we have 4. So this makes this problem a whole bunch easier. So this is just still 1 on top because this all becomes 1. Now we have a 4 squared, and we have z to the 8th or 6th. Yeah, 8. Yeah, 6 to 4. Yeah, okay. All right, so now what does that simplify to? Well, that simplifies to 1 over 16z to the 8th. Now, if we simplify this one, it's going to be a lot harder. You know, that's going to go down, and that's going to give us 4 of those, cancel 4 of those, we have 8. And then we're going to have to use our calculator and take 7 squared is 49, 28 squared, as I'm not going to do, but I'll type it in my calculator. And if I do the reduction, what we end up with is 16. And so we get 1 over 16z to the 8th. So notice both ways are the same answer. This way, when we reduced it, it went straight down this way instead of going the hard way. We got an easier solution. We didn't have to do as much reducing afterwards, and we just had to do it at the beginning. So that's probably the way I would do it. If possible, reduce first, and then after that, you can square. And so that one turns out, again, a lot easier as far as the solution goes, getting to it, but both of them end up with the same solution. All right, so here's one more, same thing. Let's go ahead and we're gonna have to take all this to that power. So we'll have x to the 7th. Now we have y to the 4 times 4 is 16. And then we have z to the -4 all over. Now we have x to the -2, y to the 3rd, and z to the -8. Now, because of this power here, I couldn't take this down already and do anything. So I just wanted to write it like this. Now I can start moving things. I can take this z to the -4 down here and make it positive. I can take this z to the -8 and take it up here and make it positive. And I can take this x to the -2, take it up here and make it positive, and then things will be nicer. So if I do that, I'll have x to the 7th, y to the 16th. Now I'll have another x squared all over. Now the z to the 4th came down. My y cubed is still here. And then this z to the 8th comes up here. Okay, so the x squared went up, the z to the 8th went up, y cubed stayed. Here the z to the 4th came down, everything up there stayed. And now we've got it into a form where we can start canceling. So 3 of these cancel 3 of those. We have 13. Z to the 4th cancels 4 of those. So we have a 4 here. So everything in the denominator is gone. So now we just simplify the numerator. We have x to the 7th, x squared. So it's going to be x to the 9th. And we have y to the 13th and z to the 4th. Now, does that work? Yep, that looks like the right answer. And so that's how I would do that one. So hopefully that helps.